All right, here we go. So last week, we started with this question, and I asked you to go and fill up the tables. I believe you have done that to a great extent. All right, so let's just finish up with this question, and then we can move on to something else quickly. Your exams are getting closer by the day, so let's get right into it. Um, Give me a minute. Let me just set my jotter here. Okay, so let's go on. So, how many of us were able to finish up and add up this table we were working with last week? Can I get a confirmation from somebody who was able to do that? And tell us what you got finally. Quickly, please. Anybody? Okay, so let me just ask, do we continue from where we stopped last week, or do I take this question number 14 again? Hello? I want a response from you guys. Do we continue from there, or do I just move on or take it again? Can you hear me?
Please, you can take it again, please.
Okay, so can you just read for us again so we know what we are doing? Example number 14. Just read for us quickly. Let's go.
Following information shows the 10-year returns on an equity fund. Compute and characterize the shape of the distribution. Then we have the year and return.
Okay, so I'm going to rush through this quickly because we have done this before. So again, I need you to get your calculator and your rough sheet handy because you're going to be doing this yourself. I'm just going to be guiding you through. So what do we need to do? The first thing we need to do, as we can see here, is to make our table. You can see the table here. You can just choose to ignore the years for now. All right, you don't really need this year column. This is just a direction. So you list all your X values in a vertical manner, 14.8%, 4.5%, all the way down. All right, please bear in mind that here, what you have is a negative 13.0%. Okay, negative 13.0%. So when you list them all down, okay, we need to find the arithmetic mean, okay, which is this here. And how do you get your arithmetic mean? You need to add this all up. Bear in mind again that this is a negative value, and then you divide by what? How many values you added up? I think this is a sum of 10. All right, so when you add this up, this will give you 116.4. 116.4. So the arithmetic mean will now be 116.4 divided by 10. And that will give you what? 11.64. That will be the arithmetic mean. Now, having 11.64 now, you want to take away 11.64 from each of these individual values here. Each of these individual values. So 14.8 minus 11.64 will give you this value. 4.5 minus 11.64 will give you this value. And we do all that all the way down, all the way down. Now, when we are done with that, okay, we need to do um this now. Okay, this one we have done here. Now, there's even a step we missed. Okay, so I'm going to just put that here and then you do that for me, which is x minus x bar, and this will be squared. Okay, so the squared should come before the cube, but it really doesn't matter so long you know what you are doing. All right, so this is this value, okay, 3.16% to the power of 3. We took our time to explain how to deduce this eventually in the last class. So I'm going to wait for you now as you're going to do this for me now to the power of 2. 3.16, get your calculator. Okay, before we move on to the square, can somebody explain to us again how we got this 0.0032% from the last class? Anybody? Quickly, let me hear from you. Are you there?
The question again, sir.
How did we arrive at this 0.0032%? coming from 3.16%. Look at this and try and get it done for me. This is your clue.
So the answer that we got from x minus x main, we raised it to power 3. That's the cube. So when we got the answer, it was in negative percentage. I mean, how do I explain it? So we had to convert it.
So can we do that? Can we do a practical? I want you to get a calculator and do it for me now. Because you're going to do this for me now for squared, not cube. So get your calculator, everyone. 3.13%, then cube. Then come back and tell me how we got this quickly.
You told us last week that because the calculation will give us a times 10 raised to power minus 5. And then that means that we must have 0.0000, then the other numbers 30664,297. But if we want to convert it to percentage, we have to, the logic you gave us was to remove 2 zeros.
Great job. And that was clear, right?
Yes, for me, yes.
Good. So quickly, we want to now go to, rather than to the power of 3, let's do to the power of what? 2, as we have it here. So by the way, when you are done with all of that, you sum up, you should get a negative 0.09334 whatever. Okay? Percent. When you sum up all of this. So I want to assume that we are done with this now, but there's a portion we missed out, and we're going to see why later. So let's do this now. The same values here, this time raised to the power of 2. Then everything we thought we learned about the manipulation still applies. So let's do this quickly and get the first value. Okay, so let's go. Waiting. I just need to give me the first value here. Okay, 3.16% squared. Then manipulate it to express as a percentage. What do you have?
That will be 0.0998.
Could you come again? 0 point what?
0.099856.
So you could go 999, right? Percent.
Yes.
Okay, so can we go through? I hope everybody understands how you got this. Who doesn't understand how this was gotten? Who doesn't understand this?
Yes, I don't understand.
Were
Please,
you in the
why are you
last class?
squaring?
Maybe not. Okay, so you want to take 3.16% on your calculator. Can you do that quickly on your calculator? You have to press. So I'm intentionally not bringing out my calculator today because I want you to try it out yourselves. 3.16, put the percentage sign, then raise it to the power of 2. Yobami, okay, I guess you are the one speaking.
9.98 times 10 is power minus 4.
Good. So I'm sure you know how to move that -4, move your point to the left. I'm sure you're able to do that, right?
Yes.
Okay, so do that and write down the answer. What do you get?
Please, sir, why are we squaring it when the formula says cube?
You're gonna see why very soon.
0.000998.
Okay.
Four
Is that clear to
zeros.
you now?
But why is it giving only two zeros here? Is it because of the percentage sign?
Yes,
Yeah.
because of the percentage sign. Yes, we did that in the last. That means you have not watched the video again, or you were not in the last class. That is just what this means. Okay, so please try and make up for that. Are we good?
Yes, sir.
Okay, so if you can, what do I do? I need you to, can we quickly rush through this for me quickly? Okay, so somebody was asking that why are we doing squared when the question is asking us for cube? We are doing squared because of something in the formula here. We are looking for squareness. This S here, who can tell me what this S represents? Who can tell me what this S represents from what we learned in the last class?
I guess queerness.
No, squareness is everything all together. So this is your squareness here. This is the squareness formula. So this S here is coming from what we
Variance.
learned previously. Let me see if you will get. I'm giving you clues. What is this? Then I told you when you have gotten this, you find the square root, and this takes off this square root. You
Deviation
have
and variance.
go. So this is variance. When you find the square root of the variance, you are left with your standard deviation. So this S represents your standard deviation. Okay. So I'm not sure I mentioned that last class. That's why I want to emphasize that now. So that's the reason why you need to find the squared, because that's an integral part of finding the variance formula. Are we good? So let's go on and find the other values quickly. So I'm waiting. I want you guys to tell me what you're getting for all these other ones. All right. So let's divide the work quickly so that it can be easy. Can we have one person do 1, 2, 3? Let me take it from here, which is this value 1, 2, 3. Another person go 1, 2, 3. Another person does 1, 2, 3 to save time. All right. Let's take it quickly. Let's take it up amongst ourselves quickly, guys. Who is doing A? Who is doing B? And who is doing C? Oh yeah, oh guys, are you there?
I'll do for C.
All right, so get on with it. 1.46% squared. Who is taking B? Please mind the signs in front of it when it's a negative. Hello, everyone. Who is taking A? Who is taking B? The person taking C, just get on with the work. You guys are not talking.
Okay, I'll take on C.
A lady took C already, so you can take A or B.
Mr. Sarako, please, I want to quickly say something before we start. So I did the submission last week, and what I got is different from what is in textbook. So I realized that while we were rounding up, I was English. While we were doing approximately, the textbook did not approximate,
Where
and they
exactly?
kept and they maintained four figures.
Leave the number of figures they maintain. Just tell me where we were
No,
approximating.
you told us to do it on our own. So me, I did my own, and I got 1.25, 1.2582. That was my submission of this X cube something. So
1
today
point what?
I got 1.25. So the difference is too big.
No, no, it shouldn't be. You should get something in this range. I did it myself and I got something
So
like
what
this.
I'm now saying is where I made a mistake. That's why I'm saying in case anybody wants to do it now that they should watch out. Is that I
Okay.
got almost all the figures, but my approximately was like maybe two this thing, and I didn't maintain four figures. So that was my issue.
Oh, so maybe we did not understand one another. Okay. I have always maintained that when you are doing your calculations, maintain four figures. I always say that. Now, the manipulation we are doing here just has to do with the percentages. So maybe that's where we got it wrong. I don't know if that's clear now. But ideally, you should round off with this number here. And again, it's even a good thing you mentioned this. You don't go beyond 4 decimal places when you are doing your workings. Okay? It's only when you are done with your workings that you now approximate your answer to be in tandem with what is required of you. All right? So the person doing C, are we done with the three values? We are spending more time on this. And some people have not even we have not had people choose A already.
Oh yeah, I will choose A. I will choose A. That's not a problem.
All right. So we have somebody doing A, B, and C now, I guess. So let's do that in the next 30 to 45 seconds. Remember, this is squared now.
But Mr. Salako,
I'm with
I
you.
don't know why I'm getting negative figure for square. It's not right because negative times negative should be positive. On my calculator, I'm getting negative. So
That's the reason why you need to learn how to use your calculator. It's even a good thing I'm not using my calculator today. So what are you doing wrong? Are you pressing the calculator before, the negative before or after? Figure that out yourself.
I put it in brackets, then I now raise it to the power of.
Where is is the negative inside the bracket or outside of the bracket?
It is inside the bracket.
So if it's giving you a negative, see, maybe you try and put it outside the bracket and see for yourself. Have you been able to sort it out? I didn't hear you.
I'm still on it, sir.
Okay.
No.
This is three. For square, it's not one person. It's not need to be like this. Anything that's around, let's say that.
Is anybody done? A, B, C with the three.
Yes, I'm done.
So which one is that? A, B, or C?
The one of C.
Give it to me. The first one, 1.46% give you what eventually?
Square, 1.46% square is
Yes.
giving 0.0002. But
Yeah.
since we are going to remove two
Uh-huh.
zeros, 0.02%.
0.0213. Can we do that?
213. Okay. Yes, sir. 0.0213.
Okay, the next one.
0.01008.
Do your manipulations. What do you get?
So 4 decimal places will be 0.0101.
I didn't get to come again. It will be what?
Without the manipulations, it is 0.01008.
So with the manipulations, what should it be?
To be one, if you are removing the two zeros, it will be 1.008.
And the last bit?
0.0607.
Final answer?
It will be 6.07%.
Or 6.0713. Please maintain your 4 decimal places until you get to the final answers so that the difference in your answers are not too big. Are we good with that?
Yes, sir.
All right. So A and B, we are waiting. Are you done? A and B. A and B. Maybe you tell us which of the three have you not done so that C can help us with one or two of them. Can we speak up quickly?
Okay, for 2001, I have 0.5098%. Then for 2002, I have 4.6916. Please, I need confirmation from others too. So that, yeah, percent.
Don't
Then
worry, don't
for
worry. I'm confirming it here. Don't worry. Okay.
okay, for 2003, I have 0.7480%.
80. I don't. Ugh, please check it up.
Seven.
What did you get?
I
0.7?
got 0.7499.
Give or take. I don't want you to be very mindful about decimals at this point. Just stick to your 4 decimals for now. The difference will not be too much. Are we good?
Even if it's 4 decimal, it won't be seven. I don't know. Maybe someone else should do it.
Okay, okay, so let's do it together again and confirm. Even though that's not
For
even what
which
I
year?
have here, but I just feel it will
For
still work.
which year?
For 1, 2, 3, 4, 5, the fifth one in the row. Abi, 1, 2, 3, for the fourth one. 1, 2, 3, 4.
2003.
Yes, 20.3%.
8.66%. 8.66 is 0.749. Okay, 0.7500. Because I'm having 0.749956 here.
That's the same thing I got. That's why I said it's too far from 7480.
Okay, I actually have 7.5 here as well. But I don't think that would even have made any much difference, but it's fine. Let's go by that. I hope we are all in
Question,
agreement
sir.
now.
Yes, sir.
Question, sir.
Are we all in agreement
For
now, everyone?
so a question.
Okay, I'm listening.
Yeah, so for 2001 and others that have negative in front of them, if you punch it in a calculator, you'd have a negative answer. But of course, I know minus times minus is plus. But why are you now having it as
It's because
plus and
you are the one that doesn't know how to impute the negative. I think a lady said this earlier, and I
Yes, I had that
asked,
issue.
so what did you do to help rectify
uh,
that? Please help us.
Minus was inside. I later put the minus in the brackets.
okay, the values in bracket and minus
Yes,
outside, right?
everything should be in
Okay,
brackets.
okay.
So please let's have this standing rule here. Going forward, everybody comes in with his or her own calculator so that you can begin to know how you need to manipulate it before your exams. All right. So who is doing B for us? Let's hear you. Who is taking B?
Okay, let me just punch it. 2000, starting from 2000 and what now? 2004.
1, 2, 3,
So
4. 1, 2, 3. 1, 2, 3, 4. That will be
70.16.
2000 and what now? 4, Abby? 1, 2,
2004, yes.
3, 4. Yeah, start from here.
I'm still
Okay, the
getting
first is
negative,
giving
even with
us the first is giving us 2.945%.
2,
2.945%.
9, 4. 9, 4, 4,
5.
5.
Okay,
Right?
94. So it's actually 2.944656, but approximating it to four
To what
decimal
now?
places. It will
To
be
what?
2 point. So four decimal places will be 2.9447. So
Okay.
seven
And
percentage.
because
please,
of space, I'm just going to try and.
I'm still getting negative, even with the fact that I put it in brackets.
No, it's a manipulation. But I don't want to bring out my calculator. I don't
So
want
what
to.
I did is minus in bracket 7.14% raised to power 2, then close bracket for 2001.
You're forcing me to bring out my calculator.
No,
Can
I
you see the
can't get
calculator?
the lady that did. Okay.
So what did you do? Tell me. Minus first or bracket first?
Minus, then in bracket. Minus, then bracket open.
Minus supposed to
7.14%
be
raised to power
inside the
2.
bracket.
Close.
You said the minus is supposed to be in the bracket, right?
Inside the bracket, yes, sir. Before the
So can
figure,
so can you try that, my brother, quickly? Open your bracket first before you put the
the
minus. Do that quickly.
-. Minus. Yes, like this.
I hope you are doing it as well.
Yes.
So what are you getting?
The raised to power is inside the bracket, so yours is outside, so I get it.
Have you seen where the mistake is now?
Thank you.
So please, one more time, always come with your calculators. All right, so bye-bye to this. So where were we? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, let's have somebody do 2005 and 2006 for us quickly. So we just write them and then we are adding up. Quickly, please.
for 2005, we have 0.05954. 595 0.05954. Okay, 595. Sorry, it will be 596 since we are approximating. It will be 596. Yes.
And then the last one.
7.84 percentage. This bracket is corruption. Is 0.0, sorry, 0.6147.
Okay, so now that we have all of these sorted, what do? We want to add them all up. Okay, I hope you have this done as well in your rough sheet of paper. So let's add up all of these numbers. You can ignore the percentage sign for now. 0.0999 plus 0.5099 all the way. Let's add it up quickly and tell me what your answer is.
I'm getting 15.7707. Others can confirm.
You should guess, did you say 15 or 16?
15.
It should be 16, though. Maybe you want to try that again. I have 16 here. 7705.
Let me check. Let me cross check my digits.
Yeah, please do.
Okay, sorry, do we have, is that 2 points? Okay, is it 2 point? Oh, that's where I got it from.
Yeah, it's 2.94,
Okay,
right?
I thought it was 1.
Yeah, it's 2.
Okay, 16.7707. 16.7707%.
All right, so we're on track. So now, why did we do all of this? Because we need to come and sort out the standard deviation part. All right? Now, how do we get a standard deviation? Who can remind me of the formula for variance first? Again, remember your variance is expressed thus. The sum of x less x bar all squared. Reason we had to come and do this, divided by, in this case, is this a sample or a population? Were we told? Let's just stick by sample here. Okay, I'm not sure we were told anything to that effect. The following information shows the 10-year returns on an equity fund. 10-year return on an equity fund. Compute and characterize the shape of the distribution. Okay, so I want to just stick to this for now. All right. It could have been, again, like I said in the last class, it could have been, emphasis could have been laid on it if you had to use the population or the sample. But I just want this to go with what I have on ground here. Is that clear? So it could have been just n as well. So either doesn't really matter, but make sure that emphasis, if it is specified in the question, yes or no. So now for this what is it called? Numerator bit. That's the sum here. We have our 16.7705%, and our n being 10 minus 1, we are having a 9. Okay, so when you do all of this, what is your variance? Somebody input this 16.7705 divided by percent divided by 9. What does that give you? Please include the percent sign. 16.7705% divided by 9. What does that give you?
0.01863. 0.0186338.
So we can stop here since we already have more than I hope nobody come and ask me how did this come about. Oh, there are two different things. So now here we have our what? Variance. So what do you do to your variance to get your standard deviation?
Raised to power 0.5.
Okay, that's the square root of your variance. And what does that give you when you do that?
0.1365.
So let me just bring that out here now. Please let this not confuse also. So our standard deviation is, take that again, 0. What?
0.136506.
4 decimals are fine. 0.1365. Now, we went through all of this to be able to get this S value here. Okay? So now that we are done with that, everything that is required in our formula is set. Remember that we are trying to find the skewness, and then we looked at the formula in the last class. So how do we impute this now? So we go, what does the formula say? N. What is our N? 10 over 10 minus 1, 10 minus 2. So allow me to just say 9 here and 8 here. I'm sure that is clear, right? 10 minus 1, 10 minus 2. Is this clear, please? Confirmation?
Yes, sir.
Okay, so we want to multiply that now, whatever that gives us, by, what did we do here? X minus x bar to the power of 3, the summation, which is this negative 0.0933 or 34, depending on your whatever it is, your approximation levels, divided by your S cube now. Okay, so we've gotten S, right? You have gotten S. Now take S now that you got 0.1365%. Okay, now take it to the power of 3. Take this value to the power of 3 according to the formula. S to the power of 3. 0.136, whatever you got earlier, to the power of 3. Do the same magic you have
Sir,
always been doing and tell me what you get for here.
please, sir, where did you get this 0.0934? Should it not be 33?
Okay. All right. So what am I getting here for S to the power of 3?
That's 0.2543.
Are you sure it's 2543 or 2544? Two five four three or 2544%?
Maybe because of the approximation.
So what should it be? 2543 or 2544? Just give me. What do you think it should be?
When I did when I just wrote 0.1365 raised to power 3, I got
Okay. So it's because you have approximated here rather than using the previous value. So it's
exactly.
fine. You can use that. You can use that 3 as well. I'm not sure this will make much difference like that. So now that we have all of this, so what we want to do, percent. So let's input this. Let's take it one by one. So what does, okay, can you input this into your calculator? Let's input this into our calculator. What does this give you? 10 divided by 72. What does that give you? Might choose to break it down. What's 10 divided by 72? Hello? Am I still audible, please?
We are with you, sir.
Okay, so what is 10 divided by 72? 9 times 8, 72. What does that give you? 10 divided by 72?
0.1389.
So approximately 0.14, right? See it here. 0.14. Then you want to multiply that by 0.0933 divided by 0.2544 or 2.543. So I think at this point, our answers are more or less the same. So if you want to, can you just do this in your calculator, then multiply that? At this point, the percentages can cut out, okay? So negative 0.0933 divided by 0.2543, whatever you have, multiply by 0.14, then we get our final answer. Can you do that for me quickly? We are using the whole session for this one question as well. The most important thing is to understand it.
0.05.
Okay, don't forget your minus, please. There's a negative sign. Negative
Minus 0.05.
0.05. All right, negative 0.05. That's our answer there. Okay, so what does this mean? Look at the interpretation. Since the skewness is negative, the distribution is slightly negatively skewed or nearly symmetric. Just stick to the slightly negatively skewed. All right. The positive and negative deviations from the mean are equally frequent, and large positive deviations offset the negative deviations. So that's that about that. Now I want us to do something again. I want to move on quickly to this kurtosis. Okay, I'm going to move on to this kurtosis quickly, and then we look at what it really entails. So kurtosis describes the shape of either the tail of a distribution, that is, whether the distribution is heavily tailed or lightly tailed. Now remember we did something like this: left tail, right tail the last time out. Okay, now this tail thing is due to what is called outliers. How many of you know Maxcom Gladwell? He wrote a book titled Outliers. Do you know what it means when we say something is an outlier? What does it mean? Any idea? Anybody?
Extreme value.
An extreme value. Beautiful. So what does that mean? If we were to find the average of 2, 3, and let's say let's do it. 2, 3, that makes 5. 5 plus, let's say, another 3, so they can be easy. 2, 3, 3. What's the average? This is 8. Is this 8?
Divided by
Let me make this 4 so that you can divide easily. So this makes 9 divided by 3. That gives us 3. And in a way, 3 is the average, isn't it? But what if I ask you to find the average of 2, 3, and 15? Let's say 2, 3, and 10. 2, 3, and 10. So this will be 15. And then 15 divided by 3 will give you 5. Now, this 5 is not, how do I put it? Is not kind of close to what should be the average value of this. This 5 came about because there's one value here that is way much bigger than the others. Imagine me making this even 40, then this will become what? 45. And then our average will be 15. Look at the set of values we have, 2, 3, and 40. All right, you see that 15 is not a realistic representation of the average of these values. But why is that the case? It is because of this outlier value here. I don't know if that makes sense. Hello?
it makes sense.
Good. So it is the presence of this outlier that is giving us this average, which is not a true reflection of the data points we considered. So you can consider 40 to be an outlier. All right. So kurtosis describes the shape of either tail of a distribution. That is, whether the distribution is heavy-tailed or lightly tailed, which means lack of presence or scarcity of outliers compared to your normal distribution. In other words, it indicates that the tail extends beyond, there's a range that we use in kurtosis. See it here, a plus or -3, plus or -3, standard deviation. Okay? So don't worry. It seems like theory now until we get into it. So just mind all these things I am highlighting. When we get into the sample, a numerical example, then you better understand it. Now we have 3 types of kurtoses. Okay, so let me just, I'm not sure this was detailed here. So we have 3 types of kurtoses. I want you to please take note of this. So we have the leptokurtic. Leptokurtic, it means heavily tailed, more than the normal distribution. Okay, so we have the mesokurtic. Then the kurtic as well. This one, it is equal to 0. Normal, same as the normal distribution. Then you have the last bit, which is platy, P-L-A-T-Y. Don't mind my spelling. P-L-A-T-Y. Platykurtic. All right? It is a short-tailed distribution, less than the normal distribution. Okay? Less than the normal distribution. Now, again, can you mention the 3 types of kurtoses we have? Let's go.
Leptokurtic,
Leptokurtic,
mesokurtic,
mesokurtic,
and
platykurtic.
platykurtic.
Mesokurtic means more than the normal. Meso equal, platy less than the normal distribution. All right. So now that we have that settled, we have the formula for our kurtoses given here. Okay. So what is the formula we were given? Am I on the kurtoses formula? We're giving the distribution here. Hold on, I just need to be sure. N into, where did this come about? Okay, so this is a kurtosis bit. Okay, so now that we have that sorted, now what I want to do is I want to hold on. Let me see how to structure this so that you can better understand this. Okay, so I'm going to bring in an example now. Okay, I'm going to bring in an example that we are going to use. Then when we are done with that example, you will now continue with what we have in example 15. Is that fine by us, guys?
Yes,
Hello?
sir.
Okay, so that we can better understand this. Okay? So please, let's write this down. Compute the kurtosis. Compute the kurtosis of the distribution Are you there?
Yes, sir.
Yes, sir.
26, 12, 16, 56, 112, and 24.
Please, can you take that again, please?
26, 12, 16, 56, 112, 24.
So is there 26 before the 12? What are you 26 before the
26 is the first one, followed by
12?
12. Are we good to go?
Yes, sir.
All right, so what do we need to do when giving such a question? Remember, we want to find the kurtosis. What type of kurtosis is it? So we go. Note this formula. Let me go on a blank sheet of paper. Okay. So again, you have to compute the kurtosis of the distribution, and then what type of kurtosis is it? So what do we do? You list out your values. So you have 26, 12, 16, 56, 112, and 24. All right. So what we need to do next is to find the arithmetic mean. So can you do that for me quickly? Find the arithmetic mean of these values for me.
40. X bar is 40.
You know you have to sum all of this up and divide by 6 to get your arithmetic mean.
41.
Sorry?
41.
Okay, so 41, eventually it is. I don't know what you got here when you summed up, but it's fine. Now, what I need you to do is to find your x again minus your x bar across board.
That's 246 over 6 is 41. 246 over 6.
I didn't hear you.
It is
I think it's
240.
stating the numerator as 246.
No, it's going to be 26 minus 41 now.
No, it's stating the numerator how we arrived at 41.
Yes, yes.
Is this clear now?
So if you want to get x minus x bar, it will be 26 minus 41.
No. X minus x bar. Yes. Yes. This will be 26 minus
So we
41.
have
Yes.
minus 15.
Okay. All the way, please.
So first is minus 15. The next is minus 29.
Minus 25 for the 1600. So for this, it will be
15.
15. Then
71.
17.
Minus 17.
Minus 17.
Are we clear, everyone?
Yes, sir.
All right. So we want to do Why is this not writing well? A bit more manipulations, yeah. So you want to do x minus x bar squared. Then when you are done with that, you also want to do x minus x bar to the power of 4. Okay, so those of you who, okay, it's a great thing you have now sorted out the negative in squared thing. So let's go. Let's get this done quickly.
2 to 5.
2 to 5, yeah.
8 4 1.
8 4 1.
6 to 5.
6 what?
2 5.
This is 2 to 5.
5 0 4 1. 4
5 0
1.
what?
4 9
1.
4 1.
1, no. 4 1, not 9. And this is what?
289 289.
289. Okay. Now, can we sum up? Or let's leave somebody to sum that up for us. Others, let's get here. Negative 15 to the power of 4.
2 to 5 square. That's 50625.
29 to the power of 4.
707281. 390625. Same as first. 50625. 254 11681. 11681. 83521.
So we got 7246 for x minus.
And here? Okay. Yeah. Sum this up. What are we getting?
So we got 26,694,358.
Okay, so I want to quickly introduce some concepts here now. All right, based on what we have done. Okay, the first one I want to introduce is what is called the second moment. Like moment, the moment it is happening. So in kurtosis, what do we mean by this? It is simply what we have here, the summation here, divided by your n. All right? So we have what is called the second moment, and we also have what is called the fourth moment. The fourth moment. All right? So let's start with that. So somebody solve this and give me what the answer is quickly.
So we got 1207.6.
It's
That's clear, right? All right, so let's go to the fourth moment now.
Why
What
are we
will be
not
the
leaving
fourth?
it in? Sorry, can I
Sorry?
interrupt? Why are we not leaving it in 4 decimal places?
Doesn't matter. Yeah. Besides, this is our final answer now. This is our final answer.
All right, sir.
Okay. Doesn't besides, do we have other numbers here? 1207.67.
Yes, we do.
So what do you have? 67 point what?
66666.
So it's fine if you do 67 or 6667. Okay? I think
Sir.
it's fine that way. Is that fine? Are we there?
It's
Now
fine, sir.
okay, so we're looking at several ways of considering these kurtosis first and foremost. So let's move on. What then is the fourth moment? Let me write it this way. What do? Go and pick the one that has to do with power 4 that we did up here, the sum. We are dividing by n as well. So that will
So
be
we
all of
got
that number.
so we
Yes,
got
go
four
on and tell me.
million. We got 4,449,059.67. 0.67.
After dividing, right?
Yes.
Good. So kurtosis is here. I'm going to stop here for today, but we'll take it up in the next class later. Okay? Kurtosis using the fourth moment, second moment method is simply dividing your fourth moment by your second moment. I hope that's clear. Then the second moment should be squared. That's the formula for kurtosis using this fourth moment, second moment method. So what does that give us? Eventually, this should, let me zoom this a bit. So you're having 444,905.67 or 667 divided by 1207.67 squared. Are we there? Are we there, guys?
Yes, sir.
All right, so what does this give us? What's the fourth moment, which you have calculated, divided by the square of the second moment?
So, sir, you just use this example to give us the formula for kurtosis, right?
Yes, we want to look at it from different perspectives. So just follow along with me. You don't worry, you better understand at the end of it all. Don't worry.
I'm getting 3.0505.
So 3.05 is just apt, right? Now remember what we said about plus or negative 3 earlier. Do you still remember we said something about that?
Yes, sir.
And we put 3 as the benchmark. So now that we are having something more than 3, what kind of kurtosis is that? Lepto, meso, or platychotic?
Lepto.
I didn't hear you.
Lepto.
Lepto, because it is what? Greater than 3. Are we good? Leptocortic. All right, so please, let's take this from here first and foremost. So what I
Question,
want
sir.
you to do.
Please, question.
Okay. Question, go
Can you hear
ahead.
me? Can you hear me, sir? Question.
Loud and clear. Go ahead. Go ahead. Go ahead.
Yeah, okay. So can you please recap? Can you please recap how you got the this plus? Because I'm not sure I heard when we were talking about it. The plus minus 3 and minus 3. Yes.
So somewhere here while I was explaining, see, I highlighted this and I told you to take note of this. All right. If you read through the notes, I even highlighted it here. It is above or below 3. But CIS did not really go as deeply as I would have loved. So that was why I had to just take you out of here for a bit. See the leptocortic dimension here. Okay? But whatever the case, just read through all of this, go through what we have done, and then you'll be fine when you look at the question again. I hope I've answered your question. Are you there?
Yes, sir. Yes.
Okay, so yeah. So okay, so that is that about that for now. For now. So please, any other question on where did I do this for goodness sake? Has it gone off? Okay. So I think every other thing here is well understood. How we got our mean, did our deviation squared for the second moment, and did our fourth moment, the deviations to the fourth power. Then we want to go ahead to do this fourth moment, second moment, and eventually divide your fourth moment by the second moment squared, like we did here, to get a value, which will now determine whether it is leptocortic, mesocortic, or platycortic. All right, so we'll stop here for today, okay, because I need you to have this base settled so that we can build on it in the next class. Please make sure you watch all the videos and you are up to speed. All right, so okay, so Madam Moshe, let me make you the host quickly. My battery is about to die. Yeah, so you've been made the host. Thank you, guys. Have a good week ahead.
Good afternoon, everyone. I'm sorry, I didn't even notice that when other lecturer left. Please, we'll be joining back the class 10 minutes earlier. So please do help to inform others. I hope you can hear me, and I'm not speaking to myself.
Sorry, I didn't get what you said last.
Okay, I said that please we'll be joining the class 10 minutes earlier. That is on 2:50 instead of 3 o'clock, so that we can finish up with what we have outstanding. So please do well to inform others in the class as well. I'll also put it on the group chat though. But please, for 2:50 we should be in class. Thank you very much. Okay, I think it's high time we start. Let me put it on mute that class has started. I hope you can hear me or can you confirm you can hear me?
Yes, ma, but there's some interfering background noise.
Okay, I think we can start now. So first thing first, I think I need to record the class. I was unable to pause recording, okay? Who was recording before?
Oh,